Hi, welcome to Cloud on Air, live webinars from Google Cloud. We are hosting webinars every Tuesday. My name is Sarthak, and today I'll be talking about building modern apps using an API first strategy. You can ask questions anytime on the platform, and we have Googlers on standby to answer them. With that, let's get started. Here's a quick look at the agenda. We are going to spend a few minutes understanding the problem, how Apigee can help you solve those problems, some of the high-level architectures which are needed to solve the problem. We are going to see a quick demo, and then we should have a few minutes for Q&A at the end. The first obvious question is, why should you even care about this topic? Why do you need to build modern applications using an API-first strategy? And the simple answer is the whole aspect of modernization is such a huge driver. We have to modernize every aspect of our life, right? We are modernizing our phones every year. We are modernizing our smart homes and all aspects of our life. And this modernization also obviously trickles down into every aspect of an enterprise or a startup, whoever you might be. If you look at the IT landscape, the software landscape, that is changing a lot. Normally over the last 10, 15, 20 years, we would talk about our legacy architectures, our websites, mobile apps, partners. Even mobile is pretty new, right? Mobile is maybe in the last 5, 10 years when it became mainstream. But that itself is changing drastically. If you look at where the world is going towards, we are talking about IoTs and connected platforms like connected cars, omni-channel strategies. The backend systems are moving more and more towards microservices. We are talking about chatbots and AI-based bots, machine learning. We are talking about various kind of cloud integrations on how to integrate across multiple clouds and SaaS applications, how to migrate your existing applications from your on-prem data centers to cloud, and how to build hybrid architectures. So these are drastically different landscape than what you have today. A lot of this also is delivered through APIs. Keep in mind, when you want to expose your data to the connected cars or to your IoTs or to your chatbots, there's an API behind all of that. The APIs themselves are changing as well, right? The designs of the APIs are changing. When we first started seriously thinking about APIs, first there was RPC style APIs way back in early 90s. SOAP became really popular in mid 2000s and all. And then now the world has more or less moved towards REST. But there are other formats of APIs like OData or GraphQL or WebSockets or gRPC. And there are so many different just design patterns of APIs which are existent, and that's a constantly evolving landscape. The security of those APIs also changes, right? So we used to have SAML or TLS based or IP based whitelisting or things like NTLM, Kerberos in the past, which has mostly given its way to things like OAuth or OpenID Connect or JWT or even Basic Auth. So what happens is, as new and newer technologies comes up, some part of your stack adopts. Let's say some part will adopt JWT or OpenID Connect, but you will have some other stack which is still running on SAML or running on mutual TLS. There's even a brand new proposal for a security standard called SPIFE, which came out last year. It's an open source standard from Google for managing service-to-service communications in a microservices world. So this is a constantly evolving landscape in terms of API security. The other thing which changes are the consumers. Previously, all the APIs which you used to have, that used to go and either serve internal applications or maybe a website or maybe one web optimized mobile app. But now you are building native applications in Android. You are building various kinds of connected experiences. You are building iOS apps, IoT apps, smart homes, all sorts of different consumers you are creating these APIs are serving up to. So all this change inevitably results in where you have an IT infrastructure where you have to manage a number of different versions of your APIs. So you might have some SOAP, some REST, you have few different versions of REST, you might have some GraphQL APIs and whatnot. You have different types of security protocols, you might have different API standards. which internally leads to inefficient developer onboardings, right? Because you need to onboard more and more developers from internal different parts of the organizations, or from your partners, or the long tail of developers, because you need different developers with different key skill sets, right? As we are going to more and more different discrete backends, different styles of APIs, how do you onboard these different developers? How do you onboard the different apps onto your platform? And how do you release faster and better the new versions of those apps? How do you manage the life cycle of the keys? Because as you have different consumers, you need to have a much better control on when a certain key can be invalidated, or when someone is not following your TNC, you can mark that as a red flag. And all of these challenges also results in a massive challenge with the overall analytics. How do you measure all the usage, errors, latency, adoption? Because you need to measure things from your operational standpoint, right? How do you, across all the different APIs, how is your average error rate, or what's your average latency? But you also need to understand it from the business standpoint. How's your adoption of the brand new API which you just published, or the brand new version of the API? And you need to understand all the usage and adoption. How is a specific type of API getting more used in a mobile app context than something else which might be more popular with IoT devices? Now we have looked at some of the problems, right? That because of this dynamic changing landscape, which your backend is changing, and your APIs are changing, and your consumers are changing. Now comes the obvious question: as part of this changing landscape, how can Apigee play a role, and how can Apigee help you evolve faster? So Apigee helps, at a very nutshell, Apigee helps by creating a platform. So if you look at the bottom half, that's where you have your Google Cloud Platform. You have your maybe some other clouds, maybe some on-premise, maybe some on-premises based system, and these are all have running a bunch of systems which are exposing data which needs to go up to different web and Android and iOS and different set of consumers essentially, right? So what's a platform? A platform is a place where you can bring these different technologies and the human aspects of the technologies, like the developers who are building those backend systems, the developers who are consuming those backend systems, the developers who are then building the apps, and then the end users of the apps. You can bring all of them together. So Apigee can help you in your journey of modernization by bringing all these different entities together. So in the Apigee platform, which sits as a facade or a proxy on top of your backend systems, Apigee will take care of things like providing you all the right analytics, from operations to from operational analytics to infrastructure analytics to business analytics. It will help you manage all the developers, the life cycle of the developers, from the developers who are producing the APIs to the developers who are consuming those, as well as all aspects of security, translation, debugging, and a whole bunch of things. And we'll see that a little later, right? But the key aspect is Apigee as a platform helps you tie back together all the technologies, both on the production side as well as the consumption side, as well as all the different human elements in this platform, helps you tie it all back together. Now, oftentimes when we are talking about this, we get asked questions that, hey, I would like to go there, right, where we create this platform, but over the years, I mainly have built monoliths, or that's what we are left with, right? So in a monolith world, you would typically have all these different capabilities like authentication, authorization, business rules, etc., all confined in the boundaries of the same application, which are then consumed by different users. That's a very, very traditional landscape in an IT world. Now, people inherently understands the problem with a monolith like that. So early 2000s, the world of SOA, service-oriented architecture, that gradually became popular and became mainstream, and that's when people started to break those individual components into individual services. We are still talking about, primarily SOAP with maybe some SAML-based security or certificate-based security. But this is how, for many of us, that's how the architecture looks like, and not really a very traditional monolith. Now, as the world evolved, right, like it's 2018 for everyone, uh, we are no longer investing new into SOA services or SAML or SOAP or things like that. Rather, the new keyword, the new buzzword is microservices. How can you build things which are even smaller and are easier to manage? And we can leverage things like containers and Kubernetes and stuff like that to grow them, to scale them in a hybrid environment, either cloud or on-prem or multi-cloud or whatnot. So now we have a lot of microservices as part of everyday stacks. If you look at how enterprises typically look today, you will probably see a combination of a whole bunch of different things. So let's start with the most obvious on the right hand side, where you can see cloud foundries and Dockers and bare metals and VMs. That's your traditional on premise environment, right? When you have a data center or a colo facility where you are either running bare metals or VMs or running containers like Docker or doing other kind of on-prem softwares. From there, some enterprises have evolved to run private cloud, where you are doing not only like Dockers, but you are actually trying to run cloud foundries and Kubernetes on-prem and trying to create a private cloud in your data center or in your colo facilities. Now, the next thing is public cloud. So you will probably be using a whole lot of GCP, maybe some other private cloud, other public clouds in a hybrid environment. And then you have the SaaS, where you might be using things like G Suite and using their APIs. So the key takeaway is this is a reality for every enterprise, whether you are a Fortune 2000 organization who has been in business for 100 years, or whether you are a startup who just started out of Silicon Valley over the last few years. Your backend, the systems from where you're consuming data and the systems to where you are exposing those data, that is becoming more and more diverse, right? So let's move on to now. Oftentimes, when you talk about this, we get the feedback that hey, this is not what our backend really looks like, right? This is probably where we would want to go, but this is not where it looks like, right? So, and that's the question which we get oftentimes, that my architecture does not look like that today. It might be true for some parts of your business, maybe for some applications, that may not be others. But that's totally fine, right? If your architecture does not look like that, and that's totally fine, because most likely your architecture looks like this. So we talked about this monolith and how monolith has been a mainstay in enterprises for many years. So this is probably how your application looks like. You have a monolith. In this case, we are talking about, let's say, a retail experience where you have a monolith application which has search, shopping cart, type ahead, recommendations, CMS, and all these capabilities running inside a data center. These are exposing all these capabilities, which are then consumed by different web applications or Android or iOS applications. So monolith exposing some APIs, which are then consumed by those web, Android, iOS. Oftentimes, you will see you probably don't even know the existence of the APIs because of two reasons. Either the monolith down below exposes you SDKs, and the SDK in turn hides those APIs, or maybe the monolith itself provides you a direct hook into the web, Android, iOS. Is the same team who builds those, and there is a very deep integration between those consumer-facing applications and that backend, right? But the challenge is that now the front end and the back end, those are very tightly integrated. So what we need to do is we need to create a proxy or a facade. We need to separate those two things out, and that's where Apigee fits in. Apigee acts as a proxy or a facade, which sits in between that backend layer where you have the monolith and you have the front end layer. So first and foremost, this gives you a tremendous flexibility on the front end team to do things differently at a different pace than what would happen at the back end. Now let's look into how will that happen in real life. So let's say you have this monolith, and now the backend team, they decided that we need to break it down, this monolith. We want to create a few microservices. Let's say we want to break down the search and the type ahead and write some new services, maybe property lookup and whatnot, which is not available today as part of the monolith backend. And now they are writing this thing in microservices, in GKE, running on Google Cloud Platform. Now, because Apigee is sitting in front of, as an abstraction layer in front of this backend, while the backend teams are making those changes, they are moving those services to Google Cloud Platform, which takes a long time, right? Which takes maybe 6 months, year, 2 years. The front end teams, they are not impacted because they are getting still those same APIs, and Apigee is taking care of translating them, meditating them, right? Like so when the Google Cloud Platform based, let's say the microservices are built, let's say the APIs might be exposed as JSON over REST, whereas the monolith might expose SOAP. Apigee will make sure that what the Android and the web and the iOS teams see, that's single uniform APIs, irrespective of what the backend is. It's the same security, it has the same versioning structure, it has the same, let's say, the layer of caching and everything else, like the backend, whether it is in a monolith or whether it is in GCP. So what it leads to is the front-end team now gets isolated. As you can see, we can now create one nice box around those different front-end teams, because you might have a different team for web, a different team for Android, different team from iOS. And now there is a nice box where they can work themselves, having at an arm's length from the backend team. So we are now trying to break away from the paradigm that the backend and the front end teams are very closely knit together, where every feature on the front end results in deep code change at the backend, right? Like where we have seen things like if you want to build a new feature in an Android app, it might result in having a stored procedure change at your database level, right? That's obviously not ideal, and it slows down the whole process. So now what you can see is maybe as part of this re-architecture, what the retail customer wants to do is they want to move everything onto GCP as different services, and they want to keep in their private cloud or in their data center, they want to keep the shopping cart application because it doesn't make sense to rewrite that as a microservice or whatnot. While they're doing that, as you can imagine, there's a massive change. They are doing massive reworking, and it is happening over years maybe. Instead of the front end team being slowing down, where they have been asked that, hey, we are making these massive changes at the back end, please make your changes slower. Instead of that, they actually added brand new capabilities. Like they might have added a new Google Home integration, or they might have added some other native mobile apps or some new web apps. So the beauty with Apigee is you can create this facade or a proxy layer where you can have the front end teams building new apps faster, going through faster release cycles of the apps, while your backend goes through this tremendous transformative changes where you are shifting your backend either from monoliths and taking it to a lift and shift to cloud, or building out a hybrid cloud, or building out microservices, breaking out your monoliths into microservices. Whatever shape or form those changes might be, Apigee will help you isolate those changes at the back end, and your front end teams will still be able to innovate at a lot faster pace than probably where they were before. Now, how Apigee does that? This diagram talks about something which is more commonly known as a two-speed IT or a multimodal IT. These are the words which have been thrown around in the IT world in the last few years. So what does it mean is down below, where you see the CRM and the financials, HR, supply chain, and all of that, that's a system of records. That's the layer which you hardly ever want to touch, right? You don't want to go and change your users' database schema every few days or every few months. Maybe that changes once every couple of years. So the pace of change over there is very, very slow in matter of years. But at the top, you have your systems of engagement. So this is where you have your, the web apps and the mobile apps, either employees apps or consumer-facing apps or partner apps and whatnot. Now, at that layer, you need to move a lot faster. You need to move in matter of days. If you have an app out in Google Play and you get a feedback that something is not right, you cannot wait for 18 months to fix it. You cannot even wait for maybe 18 days to fix it. So that's where Apigee comes in with its ability to manage the security, the scalability, the analytics, manage all the developers. Apigee helps as the acts as a cushion where it takes those system of records as the slow moving layer and makes it into a system of engagement where you can move a lot faster. So this is an example of how Apigee fits in a Google Cloud Platform context. So let's say you are writing your backend, you have the system of records down below, which are untouched, like your CRMs and financials and inventory and HR and whatnot. Then you are using Google Cloud Platform on top of that to do a whole bunch of things. You might be running Google Cloud PubSub, logging, data flow, big tables, computes, and things like that. The Cloud PubSub or the login or the business logic which is running in App Engine, those are then all exposed out to your clients, which are maybe IoTs or mobile apps or web apps or partners or whatnot. Apigee sits as a facade in between these two and makes sure all the data which is exposed from Google Cloud Platform goes through Apigee. And Apigee takes care of managing all the APIs, the security, the operational aspect, the analytics, creates a developer portal through which all the developers on the client side they can get access to those APIs easily. Do the bot protection. So if you get attacked by spams, Apigee has a built-in bot detection built in. If you want to even monetize some of those APIs, that capability also is built in as part of that platform. Now, these are the capabilities wise, right? What you are looking at from an Apigee. So if you look at Apigee, the two key trends on both sides are the machine learning and the AI, which we use at many parts of the platform. Down below is a runtime where you have the enterprise gateway and STO. Then you have a mediation engine, which takes care of security or transformation from like SOAP to REST or XML to JSON. You have connectors to which you can write in Node or Python or things like that. You can build orchestrations that one call comes in, you split it out, and a few different calls go to the southbound. Then there is all sorts of analytics, from business analytics to operations analytics. And then you have the whole developer ecosystem, where you have the API catalogs, you have client SDKs, you are taking your APIs and creating products. So Apigee kind of makes you think your APIs as individual products, just like you will treat your every other go-to-market product. And then you can create an API marketplace, or you can create, or you can actually sell those APIs using the monetization capabilities. So this is how the API platform looks like capabilities-wise at a very high level. We are going to now jump into a quick demo of everything we talked about. I have a very simple setup. The demo setup says I have two different applications, which is serving some hotels data. We got some hotels data loaded up into GCP. And then I have a Node.js app, which is running in Google Compute Engine in regular VMs. And then I have a Spring Boot app, which is running in GKE, the Google Kubernetes Engine. And both of these apps are exposing APIs, which are then proxied through Apigee and goes through different consumers. In the Apigee world, the different consumers um, are uh, are represented by apps. So I have two different apps which are consuming those APIs. One interesting thing is, so we are using the VM compute engine that is kind of reminiscent to a legacy application, right? How you would run your traditional VM-based apps. And the Spring Boot app, which is running in GKE, is like your modern application. We also have an Apigee developer portal. This is where we expose all the details of those APIs, which can then be subscribed to and then consumed by the developers who wants to build the different apps. With that, let me switch screen and jump into the demo. All right. So what you see is a picture of a nice hotel. So this is our fictitious hotel, and this is where the hotel's developer portal is. If you are not familiar with what a developer portal is, a great example for you to take a look at is go to developers.google.com, right? So this is one single page through which Google interacts with all its developers. And please keep in mind, this is not only for public use cases or for long tail of developers use cases. If you are a large enterprise, if you are building APIs internally, and if you have hundreds of developers are equal, very similar to this, like a dev portal, is extremely easy to build this platform, to build this ecosystem inside your enterprise as well. Right. So please take a look at this developers.google.com, this developer portal. And what Apigee helps you to do is build a developer portal just like that for your enterprise, either a private developer portal or a semi-private, means it can be invitation only to your partners, or you can have it a true public developer portal. So this is one such developer portal which we built for a demo. We call it Hotels Are Us. And as part of this dev portal, we have some APIs. We have some pretty simple looking pages. But let's say I have this API called CMAP Demo, CMAP Hotels. And there are a bunch of hotels APIs. Here I can see an API for get all hotels, or get a hotel using a particular hotel name, or reviews, or inventory, or whatnot. Now, what I can do is I can simply go here and I can try out this API and I can execute it, and I can see the request and the response. Now, this is based on Open APIs, which was previously known as Swagger. So when you import a Swagger definition or an Open API definition into Apigee, Apigee can automatically create this dynamic page for you. The beauty of this is without something like this, previously you would have to probably request access for an API, have to wait for a few days, if not few months, someone have to give you access. Documentations will maybe a PDF, and then you take those and then write some client code, and then only you can have your APIs, make the first call to your API. Right? This is a process which would have taken a long time, a lot of trial and errors, not easy to get support and things like that. So now with a developer portal, anyone can come and can learn about the API. At this stage, you are accessing a sandbox environment. You will not have access to the production. When you want to get access to the production, then the developer have to go in and log in right over there, and he can ask for support for various things. They can log in, they can get keys, you can then approve those keys for getting used in production, and only when you are certain about what kind of app the developer is building and things like that, you can have him use your production APIs. And Apigee takes care of creating the segregation between sandbox and the production, and how do you do app promotion, how do you certify your developer, and all that kind of stuff. All right. Now let's see an Apigee screen. So this is what we call the management UI. So when you log into Apigee at just apigee.com/edge with in your SaaS environment, this is what you are going to see. One of the first things most likely you are going to do is create an API proxy. Right. So the proxy is really the facade which is separating out your backend from the front ends. So over here I have a whole bunch of facade, a whole bunch of proxies, but I'm going to open up this particular proxy, which if you can see, it has two different backends which it talks to. So one is that legacy backend, which I talked about, which is the legacy Spring app, and the other is the more modern application. And both of these are exposed as one single application. So the immediate beauty is that when a consumer is trying to call, they are going to just call this endpoint called /v1/hotels. They don't know whether downstream it is going to the legacy application or to the modern GKE based application. That is something which Apigee can take care of dynamically and can route it to different backends. So when you move on to this particular screen called develop, this is where it becomes a lot more interesting, and you can actually see all the different get all hotels, get all hotel details, and all that kind of stuff. So these are the different API calls which Apigee is configured to process right now. And I'll not spend a lot of time on this, but this is what we call a proxy editor or policy editor, where using different kinds of policies, you can configure all sorts of things from put right amount of quota or spike arrest or caching or security and do orchestrations and version management and things like that. Let me quickly jump on to this screen called the trace. So trace is a live debugger. If you have ever written a code, you have most likely used a debugger in your IDE. So trace is such a debugger, right? So this is where I have a script running which is sending some API calls, and I can see those API calls actually coming in, and I can actually click on a particular call and I can see how the call came in, the different policies which it is invoking, like there is invoking a policy to verify API key, a policy to remove the quota policy, there are some conditions, and finally the call goes to the backend. I can actually then go down and see all the different parameters with that particular policy affected. So this is an awesome way for you to debug things in real life. And you can export this session and can do an offline tracing at a later on. Now, let me move on to a little bit different screen. So we created this UI, a very simple hotels app. If I click down below, you will actually see it has been configured to use that v1/hotels, and I'm passing an API key. So as part of the demo setup, I created two apps, right? Think of one is a legacy app and one is a modern app. Both of these apps call the same API, v1/hotels. Now, based on the API key with which the app is configured, the call will go to a different backends. So Apigee is checking at that API key and is discerning which one of the backends this particular app is configured to. So if I actually go ahead and let's just search for Seattle, and I will get all the details from that backend application, right? So this is a very, very simple demo, but what we are hoping, the key takeaway is you can see the simplicity that you are exposing one single interface to all sorts of applications, whether your legacy applications which you are scared to touch, right, because the original developer is no longer with the company for many, many years, or to the modern Android apps. All of them get the same interface, and then Apigee can dynamically redirect them to different backends. And you can do so many other things like manage different versions, manage different styles of API, different security capabilities of the APIs and whatnot. One other thing which I wanted to show you guys today is the analytics capability, because as you have more and more different styles of API, higher usage of those APIs, larger number of developers using those APIs, the analytics becomes very critical, because you need to understand very precisely how each developer or how each app is using those APIs, at what error rate, what latency, what throughput, what is the business justification for an API, and things like that. So I have one analytics which is open, which over the last 1 day is showing me what's my overall total traffic, my success versus error rate, my average response times, my traffic by different proxy. So it might be I have a users API and I have a catalog API. How do I know which API is getting used more often and at what error rate and what throughput and whatnot? I can look into things like API monitoring, which actually helps me see what are the last 5 hours of my latency or the error rate, and what is the total traffic for individual APIs. I can actually go in and can drill down and see, okay, I can configure thresholds that, hey, I want to get alerted every time the throughput goes, or let's say the error rate goes beyond 0.1% and things like that. Looks like I have a little less data than what I anticipated. So we'll move on to some of the other analytics, things like developer engagement, which is really popular with product managers. Here you can see I can look at all the different developers, the details like proxy name and things like that. Then what apps they are using, and I can then drill down and analyze individual applications. So I can say, hey, this developer is making a lot of calls from their Android app, and I want to see how is their pattern different from last 7 days versus this 7 days and things like that. There are a whole bunch of other analytics like error code analytics or geomap, which helps you to get an awesome overview of analytics data or the traffic coming from all around the world. And you can see that immediately calls coming from Virginia, and I can drill down and see where in Virginia the calls coming in from. You can see your traffic, error rate, average response times, and all those things, and how are they distributed over the world. So I'm going to pause there. This is just, please keep in mind, this is just a very high level overview of Apigee, and we have not even touched probably 10% of the overall platform capabilities. There's a lot more. Feel free to try out the platform at apigee.com. Just go and sign up, and you should be able to get the same interface as you are seeing now. And I'm going to pause there. Please stay tuned for Q&A. We have a few questions coming in during the whole session. We'll be back in just less than a minute. All right. Looks like we got a few questions during the session. Let me try to address them as best as I can. The first question is, can I use Apigee even if we are not using Kubernetes or GKE? The answer is yes. So Apigee is very much backend or platform agnostic. Apigee only cares about HTTP or HTTPS. So it doesn't matter whether you are running GKE or even whether running in GCP. You might be running your private cloud, your on-prem data centers, might be Cloud Foundry or whatever it might be. As long as that application talks HTTP or HTTPS, you can use Apigee on top of that. And you can also use other protocols using custom connectors, using things like you can talk to, TCP-based protocols and things like that. So the answer is absolutely yes, primarily HTTP and HTTPS and other protocols using custom connectors. The second question is, I don't have mobile apps. Is Apigee still relevant? Absolutely. Interestingly, you will actually see, traditionally, if you look at how enterprises have used Apigee, one of the starting points in many cases is they use Apigee to streamline their APIs internally, irrespective of where the mobile apps are, whether you have mobile apps or web apps or IoTs or whatnot. Because a challenge which typically happens in almost every enterprise of every size, that over the years people write different kinds of API, different styles, different versions, and how do you even get a good control on those APIs? Like, who are using those APIs? What's the usage pattern? What all that kind of stuff. So yes, we have a lot of customers who use Apigee with mobile apps, but whether who the consumer is, that's kind of not so much critical, as long as the consumer talks APIs or the consumer talks an HTTP, an HTTPS based protocol, right? So just to reiterate, the answer is absolutely yes for the second one. Third question, can I have different security protocols for my different APIs? This is actually becoming more and more relevant and more common because as we see enterprises who have started modernizing, even companies who are pretty new, who started their who have been in existence even for like 5 years, they may have started with something like OAuth and bearer tokens, and now you might have evolved into JWTs or OpenID Connect and other protocols, or maybe SPIFFE, which I mentioned earlier. Obviously, other enterprises who have been there much longer, they might have a lot of other older protocols like Kerberos or or SAML and whatnot. What you can do with Apigee is you can do something called a credential mediation. What it means is on the southbound, that is Apigee to the backend, you will have this individual different protocols, and the northbound side, which is the client to Apigee, you can have one standard protocol. Maybe you want to standardize an OAuth, maybe a couple of different flows of OAuth, and you can have the client talk to Apigee using just those two OAuth protocols, and then Apigee on the southbound will translate that to SAML or JWT or OpenID Connect or TLS or whatever might be applicable. Great question. The next one. Can Apigee analytics data be exported? Yes, there are a few different options. So all the analytics data which you saw and a lot of others which you did not, you can export that through an API. You can do pretty much a raw export, or there is a pretty powerful query syntax through which you can export just parts of that analytics data. And you can also, there is also native integrations with things like BigQuery, where you can directly export all the data to BigQuery so that you can do further analysis in GCP. Next question, how can Apigee manage different versions of my API? Again, great question. So, so there are two aspects to that question, right? One is how the platform can do, and one is what are the best practices of version management. So let me address the first question first. So you can manage for Apigee different versions of API or just different APIs, right? Whether you represent those versions as query parameters or through headers or through form parameters, those are just different endpoints. And Apigee will manage just as it will manage two different APIs. Apigee will also provide you analytics out of the box through which you can see how the adoption of different versions are, and you can take business decisions when to cut off a specific version, or which version is getting adoption, and how can you fine tune and adjust those. Now, in terms of best practices, we have seen a lot of versioning over the years, and we have certain best practices on whether you should do versioning through URLs or through form params or through headers, how it should vary based on the style of APIs and things like that. You can go over to Apigee blog and you can learn a little bit more about those. The final question, can Apigee manage APIs of our SaaS applications we are consuming? Absolutely yes. The answer is very similar to the first one. As long as it is an API, as long as there's an HTTP or HTTPS based protocol, absolutely Apigee can address those. So with that, that's the last question which we have. If there are any follow-ups, we are going to address those online. And stay tuned for the next session, AutoML Vision, making custom image analysis possible for every business. Thank you and have a great day.